So this is section 1. They're going to be applying triangle sum properties. It's going to start leading us into information about triangles, and eventually in chapter 4 we're going to be doing triangle proofs. Triangle proofs are a little bit easier as long as you can understand, and we're going to have a lot of acronyms like side, 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 side angle, side, and all of these different theorems, postulates, and we're also going to be introduced to a new word called a corollary, and we're going to see that in this lesson. So here is what a triangle is. It's a figure formed by 3 segments joining 3 non-collinear points. The point where the segments meet is called the vertex. Plural of vertex is vertices. Sides are made up of segments. So whenever you're referring to a triangle, you could draw a picture of a little triangle. And if I wanted to talk about this picture here, I would call it triangle ABC. And I don't have to spell out the word triangle. I could draw a little picture. Okay, so this is for identifying the parts of your triangle. Next, we're going to be classifying or naming triangles based on their sides, their side lengths. So when you have a triangle with no sides the same, it's called scalene. When you have a triangle with at least 2 sides the same, it's called isosceles. When all sides are equal, it's called an equilateral triangle. And notice the little pictures, and they've got the congruency or the tick marks on them to show the congruence. Next, we're going to classify it based on their angles. So we can name a triangle. We can call it an acute triangle, obtuse triangle, right triangle, or an equiangular triangle. When you have an acute triangle, all angles are less than 90 degrees, so you will have 3 acute angles. When you have an obtuse triangle, that means one angle will be greater than 90. And when you have a right triangle, one angle is 90 degrees. Equiangular, that means all 3 congruent angles. Next, we're going to talk about the triangle sum theorem. And this is just stating that the sum of the measures of the interior angles of a triangle is 180 degrees. So here you need to know that all 3 angles of a triangle will always add up to be 180 degrees. So here they're saying the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. And it's called the triangle sum theorem. The next theorem is called the exterior angle theorem. And the measure of an exterior angle of a triangle equals the sum of the measures of the 2 remote or non-adjacent interior angles. So the 2 angles that don't touch that outside one. So in this case, it's A and B, would be, when you add them, equals that outside angle 1. I'm actually going to do a proof for this to show you how it is created. However, once it's been proven, we can use this theorem as a reason for a proof. So I'm going to go ahead and shrink this up a little. I'm going to put in an angle 2 here just to help us out in our proof. I'm going to put a little 2 there. Okay, so to begin with, based on my diagram, I can start my proof. So based on my previous theorem, I could state that angle A plus angle B plus angle C, plus angle 2. Because notice angle C has 2 angles sitting there. So I could either, if I didn't put the little 2 in there, I could have called it angle BCA. All right? And I know that all 3 of those angles, when I add them, equals 180 degrees. And that reason would be the triangle sum theorem, which is what we just learned. So So that's my statement. I'm sorry, that's my reason. So these are my reasons, and over here is my statements. All right, what do you think we need to do next? What else could we establish from our picture? What else do we know? What do we know about angle 1 and 2? They're supplementary and they're a linear pair. So the first thing we're going to state is that angle 1 and angle 2 are supplements or supplementary. And we know that by the linear pair postulate. The next thing we're going to show is what supplementary angles mean. So I could show that angle 1 plus angle 2 equals 180 degrees. And this is definition of supplementary angles. What do you think I'm going to do next? I need to somehow get to what I'm trying to prove, which is this: the measure of angle 1 equals the measure of angle A plus the measure of angle B. Yes?
You can substitute it.
Beautiful. I'm going to use substitution. Okay, so I'm going to take angle A plus angle B is equal to angle 1 plus angle 2. And that will be substitution. Oh, and I also need an angle 2 here, sorry. Because they're both equaling 180. Let me fix that better. So I have angle A plus angle B plus angle 2 equals angle 1 plus 2. Because both of them equal 180 degrees. Now I'm going to show that angle 2 equals angle 2. And what property is that? Reflexive. Good. Now that I've established that 2 are the same thing, what do you think I'm going to do to get to what I'm trying to prove? What am I going to do to this? Subtraction property. I'm going to subtract the angle 2 from both sides. So angle A plus angle B is equal to angle 1, and that's subtraction because I subtracted the angle 2 from both sides. So now that we've proven this theorem, if they ever ask you to prove that A plus B equals angle 1, you can say by the exterior angle theorem. Everybody good on this slide? All right, next. A corollary. Okay, so far we've seen definitions, we've seen postulates, we've seen theorems. Now we're going to see what a corollary is. And a corollary to a theorem is a statement that can be proved easily using the theorem. So a possible corollary to the triangle sum theorem is the acute angles of a right triangle are complementary. So what did the triangle sum theorem tell us? That it equaled 180. Good. Now, if I've got a right triangle and I know that all 3 angles are 180, what do I need to have in my right triangle? What kind of angle? A right angle. And how much is a right angle? Okay, so if I subtract that, that shows me that the amount that's left for the other 2 acute angles is also 90 degrees. So this is how we can transform the triangle sum theorem and create a corollary, and it states that the acute angles of a right triangle are complementary. So if you have a right triangle, know that the other 2 angles that are left also add up to be 90 degrees. Next slide. I'm given two angle measures, and I want to be able to classify these as either acute, right, or obtuse. Acute, right, or obtuse. So what do you think we need to do in order to classify those? What's the first thing we should do? Isabella?
If you add them together and then you subtract them by 180.
Good. We need to find that missing third angle. Okay, so 55 plus 43 gives me 98. And then if I do 180 minus the 98, it leaves me with 82. So now I have a 55-degree angle, a 43, and an 82. Which one is it gonna be, acute, right, or obtuse? They're all less than 90, so it's acute. It's a cute little tiny triangle. All right, 43 plus 47. How much does that give me? 90 degrees. So I know that this is going to be a right triangle. 80 plus 75 is 155. So 180 minus 155 gives me 25. So this becomes an acute triangle because all three angles are less than 90. Okay, 33 plus 33 is 66. 180 minus 66 gives me 114, making it a right, obtuse, or acute? Obtuse, because it's greater than 90. And then the last one, 24 plus 66 is 90, making it a right triangle. Everybody good on this one? Next. I need to find the measure of angle A on all of these pictures. So what do we know in picture A? What can we use to find the measure of angle A? Anybody see any kind of angle relationships there?
You can find the angle of the triangle to the left, like the missing angle for that, and then that's vertical, so you find that into the other.
Beautiful. Okay, we need to realize that I have a pair of vertical angles here, and I need to first find the missing one by adding 80 and 50, and I end up with 130. Subtract that from 180, and I find out that this angle here is 50, which is vertical to this one, making my missing angle that I was looking for. 50 plus 50 is 100. 180 minus 100 gives me 80 degrees for the missing angle. Good on that? Okay, next one, B. I have two triangles here. I can see that this angle is congruent to this one. So I'm going to try to figure out what this angle is. And I can add the 60 plus 40 and get 100. Subtract it from 180. And my missing angle here is 80. And then here I can put 80, add them, and subtract from 180. You could sort of tell that they're similar, and it would end up being 60. But 80 plus 40 is 120. Subtract that from 180, and that's how we get 60. For picture C, we're going to do the same thing. Notice they have congruency marks here. So I need to find the missing angle. So I'm going to add 110 plus 30 and get 140. Subtract that from 180. And I find out my missing angle here is 40. I'm sorry, 110. The congruent angle was 40. Sorry. So this one is 40, but the one that was missing was the 110. So 40 plus 30 is 70. 180 minus 70 is 110. Everybody good on this slide? Next, last one. Here we're going to use that exterior angle theorem. What do we know about the exterior angle? What's it equal to? This thing right here, what's it equal to?
Sum of the measures of two interior.
Good. So it's this angle plus this one. So if I put an x here, so x plus 80 equals 120. I could subtract 80. And x, or angle A, is 40 degrees. For picture E, again, let's label our picture. So it's telling me the measure of angle G is 100. And it's telling me that FEH is 3 times the measure of F. I'm going to let F be X. So that angle, F, I'm going to call it X. And FEH is 3 times X. So I know if I add X plus 100, it's going to need to equal 3X. I now can group my X's and then solve. Divide by 2. X, or the measure of angle F, is 50 degrees. Now we could double check this to make sure that it makes sense. Okay, so if I put a 50 here, and 3 times 50 is 150, and then if I realize that inside plus outside is a straight angle, this is 30, and then I can double check that 100 plus 50 plus 30 is 180, so it does make a complete triangle. Yes?
How'd you get quadratic of 1
All right, because that exterior angle theorem stated that if I add these two angles, it equals the exterior one. So I added x plus 100, and I set it equal to 3x. So I define angle F as x. All right.